Now we're going to learn about determining sample size for a population mean. In order to do this, whether our population standard deviation is known or unknown, we're still going to use some estimate because now we only have one formula, which involves the population standard deviation. Or in other words, we could say that the population standard deviation squared is also called the variance. But either way, we need this estimate. And so here are a few ways that we can find that estimate for the population standard deviation. And the first is called this range rule of thumb. This is one of the more common ones that we're going to use. And the range rule of thumb just states that I can estimate the population standard deviation by just taking the range of the data, the difference between the minimum and the maximum, and divide it by 4. And that's all there is to the range rule of thumb. It's a pretty simple idea here. And the second way we can estimate this is if we have raw data, we can start the collection process to find the sample standard deviation of some of the data and then just kind of use it in place of the population standard deviation. And finally, we can use the results of some earlier study. And this is kind of the basis for those problems where you want to find the confidence interval for the mean, but you have a known standard deviation, population standard deviation. We're kind of assuming that we can use the results of an earlier study and say that the standard deviations of this new study and a previously done study are probably about the same. So that's where this comes from. And so let's just do a quick example of this. We're assuming that all grade point averages are to be standardized on a test on a scale between 0 and 4. How many grade point averages must be obtained so that the sample mean is within 0.01 of the population mean? Assume that a 95% confidence level is desired. Does the sample size seem practical? And so we know that the formula we want to use is n is equal to the critical z-value times the standard deviation squared divided by standard error. All of that is squared. And so we're starting off with this critical z-value. At this point, we've seen 95% confidence level a lot, most common confidence level. We've seen that z-score a lot, and that is of 1.96. Like we said, you're probably going to end up memorizing these z-scores for the confidence level just because you see them repeatedly. Great, we've got the critical value. Now standard deviation. In this problem, I don't see any kind of standard deviation. And looking back at our methods here, we've got essentially one of them that involves raw data. Now we don't have the raw data for this problem, so we can't use number 2. Number 3 involves research, which we don't really want to do. And so we're going to use the range rule of thumb. So we're just taking the range and dividing it by 4. And our range is just between 0 and 4. All grade point averages are between 0 and 4. And so our population standard deviation is the range divided by 4, which is 4 divided by 4, which we know is 1, using the range rule of thumb. Next, our maximum standard error is just given in the problem. We're asked how many grade point averages must be obtained so that the sample mean is within 0.01 of the population mean. We know that the maximum error is just the difference between the sample mean and the population mean, and so this is just going to be 0.01. And we've got everything we need. And so plugging everything in this formula, we get that n is equal to the quantity 1.96 times 1 squared divided by 0.01. And all of that is going to be squared. And this will give us 38,416. This is already a whole number. And so this is our minimum sample size to get a 95% confidence level. Now, when we ask the question, does the sample size seem practical? I mean, it's a little bit difficult to give a black and white answer because it depends what we're talking about. If we're sending out a survey over the internet for grade point averages, in the United States or even in the world, yes, this would probably be reasonable. We are likely to get almost 40,000 results. However, if we're using a different sampling method, like in-person surveying, maybe this would be a lot less reasonable. And so in general, we can say no, this sample size doesn't really seem practical, but the long answer is it depends on how you're getting this sample. But for our purposes, no. This is a very large sample size. And so if our sample size is a bit too large, there are different things we might be able to do. Number one, if we actually know the population standard deviation, if we can calculate that some other way or look at some recent study, if this population standard deviation is smaller, can I see how that would make the numerator smaller, which would lead me to a smaller n? So I'll need a smaller sample size. So if I know the population standard deviation, that might help our cause. If we have a larger standard error, if we have a larger number in the denominator, that would make this n smaller. So that would help us. Or what's most commonly done is we can just expand this confidence level. So if we made this a 90% confidence level, that would expand this confidence interval. And so we would have a smaller n if this number was smaller. So different things we can do about that.